So this is a brief introduction to robots, right? What is a robot? Okay, it's a reprogrammable, multifunctional manipulator. Those are the three key words: reprogrammable, multifunctional, and manipulator. It can move materials, parts, tools, special devices, okay? And it has programmed motions. It can perform a variety of tasks. That's the definition supplied by the Robot Institute of America. The word robot came from the Czech language, and it means servant or worker. So please remember that we're focused on those three words: reprogrammable, multifunctional, manipulator. All right, reprogrammable. It's a computer-based controller. It can be retaught through software. You can change the program, you can adapt it. Multifunctional, you can use it in more than one way. You can use it for a variety of things. The manipulator has it has some kind of mechanical arm. It could have a gripper, it could have a vacuum cup, it could have a magnetic attachment. It has something to manipulate objects or perform a task. So here are some different types of robots. You can see that this is a Stabile, which is similar to the ones we use in Dorian's lab. Wheeled, that's a picture of the Mars rover. Legged, that's like a little spider robot that could walk. Underwater, huge application for these now, and this is aerial, like the drones you see people talking about now. All right, why do we use robots? They can reduce labor costs. They can eliminate dangerous jobs. Guys, if you use a robot to replace a person, let's say you replace 3 people, you're going to get rid of 3 workers. But instead now you have to have somebody else who has a different skill set. What happened? Where is that new employee? With somebody that can maintain the robots, maybe somebody that can program the robots, someone who has a higher skill set. So while you may have eliminated the total number of jobs, you are going to increase the cost of the new job that's created. They have a higher skill set, right? Robots can eliminate dangerous jobs. They can work faster in some cases. They are more consistent if you have the right robot for the job. They can reduce waste in some cases. We typically say that robots do things that are dirty, dull, and dangerous, the 3 Ds. Dirty, dull, and dangerous. So dirty, think in environments people don't want to work in because the environment is dirty. Dull, jobs that are repetitive, putting the same 4 spot welds on an automotive chassis over and over and over all day. Dangerous, detonating a bomb. You could be cleaning the inside of a nuclear reactor. All those things are examples of dirty, dull, and dangerous. Those are jobs that we use robots for. So they have 5 main parts: a controller, an arm, a drive, an end effector or a manipulator, depending on what you need, and sensors. There are both internal and external sensors on a robot. Internal are used to control the position and the location of a robot. Right, this is a photo of a controller. You can see that it has an e-stop, it has a place to make connections. This is digital inputs, digital outputs, and there are indicators there. These are some analog inputs and analog outputs. This is where you connect some peripherals, and you might can read that says axis 7 and axis 8. The controller is the brain of the robot. It executes the program that's written and loaded on it. It does it exactly. So remember, if the robot's not doing what you want, it's doing what you told it to do. All right, robots come in all shapes and sizes. The picture here is of a Denso robot. They position the end effector and sensors to perform whatever their task is. They have to be strong enough to carry the required weight. The required weight we normally say is the payload, right? And they must have whatever the required or desired level of accuracy and flexibility is. So you may pay more for one that can carry a heavier payload. You may pay more for a robot that has more degrees of freedom, more accuracy, right? More flexibility. These things all cost. All right, drives. That's the system that actually makes the robot move. In our classroom, we have the jointed arm robots, the Scorebots, and they have electric drive system. Drives could be electric, pneumatic, hydraulic, or a combination of drives. If you think about it, you may know already which kind of drive would you use for a very heavy payload. That would be hydraulic, right? If you wanted something that was very quiet and also very clean, you might use electric. Most medical robots have electric drives. All right, pneumatic has specific applications as well, and there could be places where you wanted a combination. So the end effector is kind of like the hand on the end of the robot, or it could be a tool to perform a task. It could be grippers or a vacuum pump like a suction cup, a tweezer, a cutting torch. The picture here, this is an ABB robot that appears to either be cutting or welding maybe, and this one is going to drill over and over. That looks like a Denso robot. This is an ABB robot. All right, sensors provide feedback to the robot on its position. Okay, they may also, that would be internal. They may also provide information on what's outside. All right, so if we look at a encoder, all right, we use that to determine the motor position and limit switches. So these two things are on all the motors of the robot to help control the position and control the homing. This is, these are various sensors. That's a ping sensor. This is a color sensor, it looks like. A variety of sensors. This one of these, that appears to be an accelerometer. Those could be external sensors that you used in combination with the robot. All right, on the Scorebot, we have a variety of things. Okay, so let's first go over the anatomy of the robot. Here at the bottom, this is the base, all right? And you can rotate back and forth on the base. Then we have the shoulder, okay? And now it's just like an arm, all right? So you're gonna have the shoulder here, the elbow, and then the wrist. And the wrist has pitch and roll, so it can move back and forth this way, or it can rotate around, all right? And then you have the gripper here, right? And there are motors. Here's a motor, here's one, there's some inside here, there's a motor, here's one, there's some there, okay? And the motors are controlled by encoders in these boxes on top here, here, here. Those are optical encoders, and they're also limit switches. You can see right there, that's a tiny little limit switch. There's a cam on this dial that when it rolls into a certain position, it'll make contact with that very tiny limit switch.